Okay, guys. That's right, the last section, Fritz.
Yes.
I was so kind of.
So this says independent and dependent events. Now listen, two events are independent events if the occurrence of one event does not affect the probability of the occurrence of the other. And I'll explain it in a minute. The probability of independent events is equal to the product of the probability of each event. So all I do is I figure out what the probability of each event is, and I just multiply them together. Okay? Now, two events are dependent events if the occurrence of one event does affect the probability of the occurrence of the other. Okay? Now, the probability of dependent events is equal to the product, that means we're going to multiply them, of the probability of the first event and the probability of the second event after the first event happens. So I have to wait and see what happens with the first event to figure out what the probability of the second event is going to be. Okay? So let's look at a couple of examples here. This first one, this is pretty easy. It says, tell whether these events are independent or dependent. First, you toss a coin and it shows heads. You toss a coin again and it shows tails. Now that was two events, right? You flipped it the first time and then you flipped it the second time. Is the second event dependent on what happened in the first event?
No.
Cole?
No.
No. So we would call these what, Tut?
Independent.
They'd be independent events, right? If I flip the coin and it lands on heads the first time, that doesn't mean that it can't land on heads again. Okay? The second event is not dependent on the first event. So they are called independent. It doesn't matter what happened first. The same thing can happen again. All right? Now look at this next one. It says, you randomly draw a name out of a hat. Then, without putting the first name back, you randomly draw a second name. Now let me ask you this. Does the probability of the second event, does it depend on the first event? Armand?
Yes.
Yeah, it does. Because as soon as you pull out one, now there are fewer names in the hat. All right? So let's take a couple of examples. I'm just going to make some up. Let's look at the first one, where it said A, right? What's the probability of flipping a heads on the first time you flip it, Simon? 50%, or 1 out of 2, right? Okay. What's the probability of flipping a heads on the second time? What's the probability of that happening, Cole?
1 out of 2.
1 out of 2. It didn't change, did it? It's still 1 out of 2. It's not like once it flipped heads, it went away. Right? If I flip it, it can still... So what's the probability of it landing heads on 2 separate flips? 1 out of 4. I just multiply. Okay? Now let's say that I've got 10 guys' names in a hat. Okay? And I want to pick a person. Let's say, you know what? Well, yeah, let's say I've got 5 guys. Let's say I've got Tut, I've got Albert, okay? I've got Fritz, I've got Zachary, and I've got Armand.
Armand.
Okay. Now, what is the probability that I'm going to choose Tut and then Fritz? Now I'm going to pull one name out. I'm not going to put it back. And then I'm going to pull another name out, a second name out. Well, what's the probability that the first name is going to be Tut? Kai?
1 out of 5.
1 out of 5. But what's the probability, Nikki, that the next name will be Fritz?
1 out of 5.
No. No, Fritz.
1 out of 4.
1 out of 4.
Yay.
Because I've already pulled Tut's name. I pulled the name out already. So the probability that I'm going to get Tut and then Fritz is 1/5 times 1/4. And that's going to give me 1 out of 20. That's the probability that I get Tut and then Fritz. Does that make sense?
Yay.
All right. Good job, guys. Let's look at the next example.